11th एंड 12th स्टैंडर्ड के मैक्सिमम स्टूडेंट्स को आइसोमेरिज्म कंसेप्ट के बारे में बहुत बड़ा कंफ्यूजन रहता है। मैं इस वीडियो में एक अद्भुत ट्रिक दूंगा। इस ट्रिक से आप आसानी से जेई और नीट रिलेटेड क्वेश्चन कर पाएंगे और साथ ही साथ बोर्ड में पूछे जाने वाले आइसोमेरिज्म रिलेटेड क्वेश्चन भी आप कर पाएंगे। हियर वी गो। सबसे पहले देखेंगे हाउ टू रिमेंबर द डिफरेंट टाइप्स ऑफ आइसोमर्स, द मेगा ट्रिक। आइसोमेरिज्म दो टाइप के होते हैं, स्ट्रक्चरल आइसोमेरिज्म एंड स्टीरियो आइसोमेरिज्म। स्ट्रक्चरल आइसोमर्स स्ट्रक्चर्स में डिफर करते हैं और स्टीरियो आइसोमर्स स्पेशियल अरेंजमेंट दैट इज 3 डायमेंशनल अरेंजमेंट में डिफर करते हैं। सबसे पहले हम देखेंगे टाइप्स ऑफ स्ट्रक्चरल आइसोमर्स एंड ट्रिक टू रिमेंबर डिफरेंट टाइप्स ऑफ स्ट्रक्चरल आइसोमर्स। टाइप्स ऑफ स्ट्रक्चरल आइसोमर्स के लिए मेरा ट्रिक है, मेरा सुपर ट्रिक है। देखो याद रखना, चेन पे मुफ्त रिंग। आई रिपीट द ट्रिक। देखो, चेन पे मुफ्त रिंग। चेन से बनेगा चेन आइसोमेरिज्म, पे से बनेगा, प से बनेगा पोजीशन आइसोमेरिज्म, म से बनेगा मेटामेरिज्म और फ से बनेगा फंक्शनल आइसोमेरिज्म और त से बनेगा टॉटोमेरिज्म। रिंग से बनेगा रिंग चेन आइसोमेरिज्म, रिंग चेन आइसोमेरिज्म। देखो, आई रिपीट द ट्रिक। चेन पे मुफ्त रिंग। चेन से बनेगा चेन आइसोमेरिज्म, प से बनेगा पोजीशन आइसोमेरिज्म, म से बनेगा मेटामेरिज्म, फ से बनेगा फंक्शनल आइसोमेरिज्म, त से बनेगा टॉटोमेरिज्म, रिंग से बनेगा रिंग चेन आइसोमेरिज्म। These are the different types of structural isomerism. These are the 6 type of structural isomerism we have to study. Once again, I repeat the mega trick how to remember the types of structural isomers. That is chain पे मुफ्त ring. Chain पे मुफ्त ring. Chain से बनाओ chain isomers, प से बनाओ position isomers, मुफ्त से बनाओ metamers, फ से बनाओ फंक्शनल आइसोमर्स, त से बनेगा टॉटोमर्स और रिंग से बनेगा रिंग चेन आइसोमर्स। अगर आपको पूछा गया व्हाट आर चेन आइसोमर्स, सिर्फ आपको इतना लिखना है, कंपाउंड्स हैविंग सेम मॉलिक्यूलर फॉर्मूला बट डिफर इन द साइज ऑफ कार्बन चेन आर कॉल्ड एज चेन आइसोमर्स एंड दिस फिनोमेना इज नोन एज चेन आइसोमेरिज्म। आई रिपीट, compounds having same molecular formula but differ in the size of the carbon chain are called as chain isomers and this phenomena is known as chain isomerism. Now let us see these different types of isomers with different examples. सबसे पहले जानेंगे isomers और isomerism क्या होता है। मान लो हमारे पास 10 रुपीज है। 10 रुपीज से हम एक पेन भी खरीद कर सकते हैं, चाहे हम 10 रुपीज से कैंडी भी खरीद कर सकते हैं, चाहे हम एक नोटबुक भी खरीद कर सकते हैं। देखो, इन तीनों चीजों का अमाउंट 10 रुपीज ही है, लेकिन दीज आर 3 डिफरेंट थिंग्स। देयर यूजेस एंड देयर प्रॉपर्टीज आर डिफरेंट। कुछ इसी तरह नेचर में भी होता है। मान लो नेचर के पास C5H12 5 कार्बन एटम्स और 12 हाइड्रोजन एटम है, तो नेचर क्या करेगा? नेचर it can arrange the 5 carbon atoms in this way, or nature can arrange the 5 carbon atoms in this manner, or nature can make a difference and it can arrange the 5 carbon atoms in another way. देखो, हर एक कंपाउंड में 5 कार्बन एटम्स है और चलिए हाइड्रोजन देते हैं CH2, 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 CH3, here CH3, CH2, CH, CH3, 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 CH3. If you count the number of carbon atoms and number of hydrogen atoms are same. मान लो नेचर के पास 5 कार्बन एटम्स और 12 हाइड्रोजन एटम्स है. नेचर 5 कार्बन एटम्स को स्ट्रेट चेन में लगाकर एक कंपाउंड बना लेगा, या नेचर 4 कार्बन एटम्स चेन में और एक कार्बन एटम का ब्रांच बना लेगा, या नेचर ऐसा भी बना सकता है 3 कार्बन एटम्स चेन में और 2 ब्रांच बना लेगा. यानी द नंबर ऑफ कार्बन एटम्स and number of hydrogen atoms in all these 3 compounds is same, that is C5H12. But if you see here, the structures are different. The content, that is किस तरह हम पेन, कैंडी और नोटबुक खरीदी करते वक्त में जो अमाउंट हमने यूज किया है वो सेम था. कुछ इसी तरह ये तीनों कंपाउंड में जो कंटेंट है, that is number of carbon atoms and number of hydrogen atoms, they are same, but these 3 are different compounds. These 3 are different arrangement. Therefore, these 3 compounds have different properties and different uses also. चलिए और एक एग्जांपल लेते हैं. नेचर के पास 2 कार्बन एटम, 6 हाइड्रोजन एटम और 1 ऑक्सीजन एटम है. तो नेचर एक कंपाउंड इस तरह बना लेगा CH3, CH2, OH, और दूसरा कंपाउंड इस तरह बना लेगा CH3O, CH3. If you see, these 2 compounds have same molecular formula C2H6O, and if you see this compound also, this has also 2 carbon atoms and 6 hydrogen atoms and 1 oxygen atom, and these 2 compounds, they have same molecular formula but they have different physical and chemical properties. This is ethanol and this is in liquid state. Ethanol, it exists in liquid state, and this is dimethyl ether, this exists in gaseous state. Therefore, they differ in physical property, and if you consider their chemical properties also, they also differ from each other. If we react ethanol with hydrogen iodide, we get ethyl iodide, that is CH3, CH2I and plus water. And if we react dimethyl ether with same hydrogen iodide, we get methanol plus methyl iodide. Now we are able to answer what are isomers and what is isomerism. We can define isomers as compounds having same molecular formula. I repeat, compounds having same molecular formula, but different physical and chemical properties. Are called as isomers. I repeat, please note down this definition. Compounds having same molecular formula but different physical and chemical properties are called as isomers, and this phenomena is known as isomerism. Now let us see chain isomerism. I write CH3, CH2, CH2, CH3. If I count the number of carbon atoms, there are 4 carbon atoms and 10 hydrogen atoms. Another compound I write CH3, CH, CH3, CH3. If I count the number of carbon atoms 1, 2, 3, 4 and number of hydrogen atoms 3, 6, 9, 10. That means these 2 compounds, they have same molecular formula but they are differ in the size of the carbon chain. This compound has 4 carbon atom in its parent chain, and this compound has only 3 carbon atoms in its parent chain. Therefore, these two compounds have same molecular formula, but they have different carbon skeleton. They have different carbon chain. Therefore, these two are chain isomers of each other. Now let us take one more example, C5H12. All these 5 carbon atoms may be in straight chain like this, or 4 carbon atoms in the straight chain and 1 branch, and another possibility is 3 carbon atoms are in straight chain and there are 2 branches. Here I have not mentioned the hydrogen atoms. You can understand very easily. See, if we see the first compound, the 5 carbon atoms are in straight chain, therefore it is called as normal pentane. The name of this compound is normal pentane. If you see the second compound, there is a branch on second carbon atom. The compound having branch on second carbon atom, it is called as iso. Therefore it is called as isopentane, because there are 5 carbon atoms. Therefore it is called isopentane. And if you want the IUPAC name of this compound, you have to number the longest chain 1, 2, 3, 4. And on second carbon atom there is 1 methyl group. Therefore it is called 2-methyl. And the longest chain is of 4 carbon atoms. Therefore it is called butane. So this is the IUPAC name of this compound, 2-methyl butane, and this is common name isopentane. And if you see this compound, when there are 2 carbon atoms on second carbon atom, it is called as neopentane. It is called neo. So there are 5 carbon atoms, so we have to call it as neopentane. And if you want IUPAC name of this, you have to number the longest chain. There are 3 carbon atoms in the longest chain and there are 2 carbon atoms on second carbon atom. Therefore this is called 2,2 methyl, 2,2 dimethyl, dimethyl. 3 carbon atoms means propane. This is the IUPAC name of this compound. And these three are chain isomers of each other. If you see the compound 1, the size of the carbon skeleton is of 5 carbon atom. And if you see the carbon skeleton in second compound, it is made up of 4 carbon atoms. And if you see the carbon skeleton, the size of carbon atom, the size of the carbon chain in third compound, it is of 3 carbon atoms. That means these 3 compounds, they are different in the carbon chain, that is the size of the carbon chain. Therefore these 3 compounds are differing with each other in the size of the carbon skeleton, that is size of the carbon chain. Therefore these 3 are chain isomers of each other having the molecular formula C5H12. Now I give you the trick for chain isomerism. Chain isomerism, you have to remember same molecular formula but different carbon chain. I repeat, chain isomerism, you have to remember chain isomers, same molecular formula but different carbon chain. Now let us see what is position isomerism. Compounds having same molecular formula, same size of carbon chain. I repeat, compounds having same molecular formula, same size of carbon chain, but differ in position of double bond or triple bond or functional group or the substituent are called as position isomers. I repeat the definition. compounds having same molecular formula, same size of carbon chain, but differ in the position of either double bond or differ in the position of triple bond or differ in the position of functional group, or they may differ in the position of substituent, are called as position isomers, and this phenomena is known as position isomerism. Now let us take one example. CH3, CH2, CH2, CH, CH3, CH3. This is one compound. I write another compound. CH3, CH2, CH, CH3, CH2, CH3. If we count the number of carbon atom and hydrogen atoms, there are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That means there are 6 carbon atoms, and if we count the number of hydrogen atoms, 14 hydrogen atoms in this molecule, and in this compound also there are 6 carbon atoms and total 14 hydrogen atoms present here. That means these two compounds have same molecular formula. And if we see the size of the carbon chain, the size of the carbon chain is 1, 2, 3, 4, 5. The chain is made up of, parent chain is made up of 5 carbon atoms. And if we count here 1, 2, 3, 4, 5, and this carbon chain is also made up of 5 carbon atoms. That means these two compounds, they have same molecular formula, but they have same size of carbon chain, but they are differing in the substituent. Here substituent is present on second carbon atom, and here the substituent, same substituent, that is methyl, it is present on the third carbon atom. Therefore, these two are position isomers of each other. The name of this compound is 2-methyl. There are 5 carbon atoms, therefore this is pentane, 2-methyl pentane, and the name of this compound is 3-methyl pentane. These two are position isomers of each other. Please take the screenshot of this. Now let us take 2 more examples of position isomerism so that we can understand very clearly what is position isomerism. Now I'll take one more example. I write CH3, CH2, CH2, Cl, and one more compound CH3, CH, Cl, CH3. If we count the number of carbon atoms in this compound, there are 3 carbon atoms and total number of hydrogens are 7 and 1 chlorine atom is present. And if you count here, there are 3 carbon atoms and 7 hydrogen atoms and 1 chlorine atom. That means both the compounds have same molecular formula. Now let us check for the size of the carbon chain. The carbon chain is made up of 3 carbon atoms, and here also it is made up of 3 carbon atom. That means these two compounds have same size of carbon chain. Now let us see the position of the substituent. Here the chlorine atom is substituent, here the chlorine atom is substituent, and the chlorine atom is attached to first carbon atom in this compound, and in this molecule the chlorine atom is attached to second carbon atom. Therefore these two are differing in the position of the substituent. Therefore these two are position isomers of each other. The name of this compound is 1-chloropropane, and the name of this compound is 2-chloropropane. Here this number indicates the position of the substituent. Here this number indicates the position of the substituent. Therefore these two are position isomers of each other. Now let us consider one more very important example. Consider this example. CH3, CH, double bond, CH, CH3. Another compound, CH2, double bond, CH, CH2, CH3. Now, if we find the molecular formula of this compound, there are 4 carbon atoms, 1, 2, 3, 4, and number of hydrogen 3, 4 plus 4, 8 hydrogen atom. And if we find the molecular formula of this compound, there are again 4 carbon atoms and number of hydrogen atoms 3 plus 2, 5, 6, 7, 8. 8 hydrogen atom. That means the compounds, these two compounds have same molecular formula. And let us check out for the size of carbon chain. This is made up of 4 carbon atoms and this also made up of 4 carbon atoms. Therefore, the size of the carbon chain in these two compounds is same, that is 4. Therefore, they have same molecular formula and same size of carbon chain. Now, let us check out whether are they differing in the position of multiple bonds. If we number the carbon atoms 1, 2, 3, 4, here the double bond, it starts from second carbon atom. Therefore, the name of this compound is but, and the double bond starts from second carbon atom. Therefore, it is 2-ene, but 2-ene. And if you count the number of carbon atoms 1, 2, 3, 4 and the double bond starts from the first carbon atom, therefore we have to mention the position of the double bond. So its name becomes but 1-ene. And if you observe these two, they have same molecular formula C4H8, same size of carbon chain, but they are differing in the position of the multiple bond. Therefore, these two are position isomers of each other. Please write down these examples. I take one more example. This is 2-nitrotoluene and this is 4-nitrotoluene. If you count the number of carbon and number of nitrogen, oxygen and hydrogen, they are same, but you can observe here clearly the position of the nitro group is different. These two compounds, they are differ in the position of the functional group. Therefore, the position of the functional group is different. Here it is at ortho position and here functional group nitro group is present on para position. Therefore, these two are position isomers of each other. Remaining types of isomerisms we will see in the next video. Thank you so much for watching. Please like, share, subscribe my channel. I am thankful to YouTube and millions of YouTube viewers.